I'm Valentin Wegner. I'm a scientist here at Dynamic42, and I'm working on the development of sensors and how to integrate them in our present organ-on-chip models. Together with PyroScience, we developed the first commercially available, fully integrated oxygen measurement in an organ-on-chip system. And with this technology, we are able to continuously monitor oxygen levels within our system. The oxygen sensor kit includes the Dynamic42 biochip, including oxygen sensor spots, the fireplate designed by PyroScience, a specifically manufactured holding frame for the Dynamic42 biochip, all microfluidic equipment, and if not already present in the lab, it's also possible to include a pumping system into the kit. The customer can use any of our organ models built up in our sensor chip, connected to a pump in an incubator, and place it on the fireplate. The fireplate is then connected to a computer outside the incubator, and there all the settings can be done, from choosing the unit of oxygen measurement and also view the live measurements during the experiment. The Dynamic42 biochip consists of two chambers, each having a top and a bottom channel. In the top channel we have one sensor spot, and in the bottom channel we have two sensor spots, one on the inlet and one on the outlet. The oxygen levels are measured through the red flash technology. This measurement is contactless, without any interference with the cells or tissues within our biochip. This leads to robust and reproducible measurements of the oxygen levels within our models. In the example of our intestinal model, we are measuring the O2 concentration in the top channel, and in the bottom channel we can measure oxygen consumption, as we have a sensor spot at the inlet and the outlet of the biochip. In the software we can monitor the oxygen levels live with a separate curve visible for each of the sensor spots present. The oxygen measurements open a wide range of applications within various organ-on-chip models of Dynamic42. Foremost is the measurement of anaerobic or hypoxic conditions in the intestinal model, especially to really confirm the growth conditions for anaerobic bacteria. Then, for example, oxygen levels in diseased conditions like cancer or cancer microenvironment, or also in our lung model for diseases like COPD. Additionally, drug treatments can be influenced by or itself alter oxygen levels within our cells. In a drug test we did here, we were able to reversibly inhibit the respiratory chain, preventing oxygen consumption within our intestinal model. This we could live monitor, all while measuring oxygen levels through our sensor spots.